So my name's Dr. K. Please refer to me as such. And today I'm going to be going over Quai Network, a brief introduction. So before we get into Quai Network and why we're building Quai Network, we first need to define what a cryptocurrency is and what the value of a cryptocurrency is. So the interesting thing sort of in my journey with blockchain and crypto, the cryptocurrency piece of it was actually not the most difficult thing to understand. It was rationalizing the fact that cryptocurrency is more closely related to our current monetary system in fiat than it is different, right? It's kind of like 90% the same and only 10% difference. And the educational hurdle is really understanding how our financial system works. And once you understand that, blockchain and cryptocurrency makes a lot more sense. So I want to draw a parallel here between the two systems to kind of set the basis for why they're the same and why they're different and what value proposition crypto can bring to the world. If we see here on the left, we have a piece of the traditional financial system. So we have commercial banks, Chase Manhattan, Bank of America, and each one of these banks has independently held ledgers. And those ledgers reflect the balance in your account. And when you go to those banks, it is their prerogative to decide if they want to honor that balance or not. And those balances are isolated and independent. So if I go to Chase Manhattan Bank, and that's where I have my balance, I can't walk into a Bank of America and ask for cash. I need to do a transfer between the two. So to facilitate that, they have interbank relationships, or they'll use something like ACH, or as a consumer, you may use something like Visa or Amex to create transactions between these disparately held ledgers. If we look at a blockchain is a set of computers running software or nodes that are interconnected by the network, and they all keep a shared copy of a ledger rather than an independent copy of a ledger. Now, the other thing that they do is if we look at the traditional financial system, each one of these banks and their ledgers have to meet certain rules as being a member of the Federal Reserve System and being FDIC insured. So they have audit systems where they come in and they'll have an independent third-party auditor like PwC, et cetera, that will audit their books periodically to make sure that they're meeting the required reserve ratios, that they're managing risk correctly. With a blockchain system, those check marks are indicating that with every transaction that's made on a blockchain, there's an instantaneous audit of that transaction in the ledger by all nodes when that transaction happens. So instead of having periodic audits of flexible rules that are opaquely enforced, we have instantaneous audits that happen all the time. So what about the monetary policy? If we look at the traditional financial system, the Federal Reserve technically dictates the interest rate. It's not a market-discovered phenomena. And they dictate that, again, on a flexible criteria. Some people say there's a dual mandate or there's a singular mandate. Are we trying to get full employment? Are we trying to hit 2% inflation? Well, maybe inflation's high these days, so why don't we change our mandate to 3% inflation? It's kind of how the Federal Reserve operates. Now, they work with the Treasury Department, and the Treasury effectively issues bonds, which are paid for with new notes to the Treasury, which then go into circulation. Right? So the Department of Treasury creates money out of thin air. The the Department of Treasury creates a bond, which is a debt, I suppose. Then the Federal Reserve creates money out of thin air to pay for that debt and then gives it to the government. Right? So the legislature plus the Treasury plus the Federal Reserve dictate what our money supply is, what our money velocity is, at the whim of the legislature, the politicians, and the people within the Treasury and the Fed. So there's no deterministic supply, and it's a politically answered question and policy at any given point in time. But if we look at blockchain, we have algorithmically deterministic monetary policies that everyone can see, everyone can agree to, and the incentives of the system are set up in such a way that the participants are in opposition, which maintains the rule set which is agreed upon. So if you think about Bitcoin, your miners are kind of in opposition with your users are in opposition with your miners. So that makes it such that it would be difficult for Bitcoin to change the thing that is Bitcoin. Now, let's say we actually want to do something in this financial system. Let's say we want to do a commercial contract. what do we need to do in the traditional financial system? We have to pay a lawyer, we have to write up a contract. How is that contract enforced? We have judges and we have local courts that have to interpret the loose language of that contract written in English at the time that we want to enforce that contract. Now, additionally to that then can percolate up through appellate courts, circuit courts, and the Supreme Court, which then ultimately is supposed to interpret the loose language of the legislature, which can change from time to time on the interpretation of how contracts can and can't be enforced. In a blockchain system, we can create a virtual machine where we can have deterministic contracts with deterministic outcomes using language that can't be changed. So what is the fundamental value proposition of cryptocurrency? And what does crypto offer as a technology that hasn't been previously offered before? So here I like to draw the analogy to the internet. And in the internet, we have the TCP/IP stack. And there's different layers, some of which you guys are familiar with, some of which you may be unfamiliar with, but Ethernet, I think people know of. That's the physical layer. IP, people know of because we use computers with IP addresses. TCP, you may or may not know, depending on who you are. But then what about the application layer? Does anybody know what FTP is?
File transport protocol.
What about HTTP?
Hypertext transport protocol.
What do we use it for?
Application transmission.
So we use it to browse the internet, right? Everybody uses it every time they go to google.com. They may or may not know it, but they're taking advantage of that protocol. SMTP. So SMTP is email. So everyone also uses SMTP every single day, but we don't even realize the protocol is there. And one of the things that has been interesting with blockchain or cryptocurrency is fundamentally it is also one of these low-level application protocols. They aren't the application themselves. It isn't the front end itself. You should be able to use crypto. You should be able to use blockchain in a way like you use email every single day and not even know it's really there. And as we remove the limitations on what blockchain can accomplish, it'll become as transparent as HTTP and SMTP. And the fundamental value proposition that makes it different than any other technology that has come prior to it is that it's a transfer of value and not information. Because right now in our world, without crypto, without blockchain, there is no way to digitally transfer value. There's only a way to transfer information. So that is the fundamental shift that we're trying to achieve, is the ubiquitous transfer of value instantaneously and globally. Yeah, so what exactly is a blockchain and how does a blockchain relate to crypto? So a blockchain itself really fundamentally has to have three things. It has to have a commitment, it has to have a link to a prior block, and it has to have a reference to data in that block. Now, the difference between a blockchain and a cryptocurrency is that a cryptocurrency is a blockchain, but it has an economic commitment. So, and the strength of that economic commitment is what dictates the immutability of the ledger that we're committing to. So if I'm talking about a transfer of value and I'm talking about needing to finalize that transfer of value so that I can't roll it back, so I can't mutate it after it's taken place, I have to have an expensive commitment to make the ledger immutable. So the difference between a blockchain, which is just a data structure, and a cryptocurrency is that we have to add a consensus mechanism, which is economically expensive to make the record of the blockchain progress forward in time and not be able to be rolled back or changed after the fact. Any questions on that part? This is a good stopping point if anyone has any. Mike?
How does blockchain help with the double spend problem that banks are currently solving?
Right, so the rules of a blockchain are something that you can, the consensus rules are something that you can add to a blockchain. So as part of the consensus piece, the economic commitment, one of the rules in Bitcoin is that you can't spend tokens twice, right? And so the way that that is enforced is through the use of public-private key pairs, such that when you make a signature and the blockchain updates in a block, that signature that creates that transaction becomes permanent, and you will no longer be able to make a new signature which conflicts with that signature, and the blockchain will honor it. So that is how the blockchain effectively solves the double spend problem, which banks currently do, but it does that in a trustless way. Whereas a bank is a trusted entity that, if we look at that graph a few things ago, you can see that that's a very trusted system, that's a very political system, and that's a very dynamic system relative to what the rules are and how they're enforced.
So in your comparison to the standard banking system and cryptocurrencies, the standard banking system is sort of doing their best to ensure that they're responsive. The Fed aims to be responsive as possible, adjusting interest rates, targeting certain inflation metrics, and sort of these moving points that they deem important to hit. How do we ensure, outside of the fact that the Fed is being responsive enough or not, how do we ensure that these crypto systems are responsive and are not essentially archaic in their economic policy?
Great question. There's many layers to this onion that we will try to unwind here. So the first thing is the Fed and their targets, in my mind, are a gaslighting justification for having the Fed itself. It is not actually in their best interest. Well, maybe in their mid to long-term interest, like it is there, but that's not their purpose. Their purpose is to say that those are the targets justifying the existence of the Federal Reserve so that they can control and manipulate the money. And then they can do that with the politicians. They can have a monopoly on it, right? And then the bankers benefit and the politicians benefit. So like that is the purpose of the Fed. They tell you that their reasoning is they must dampen the animal spirits and like smooth out the cycles. But if you look at the last 100 years of history with the Fed in existence, I think there's very good arguments to say that they don't dampen out cycles, that they actually create worse bubbles than you would have in a natural system, that they create moral hazard, and with that, bad behavior. So that's one piece of the question. The second piece of the question was,
how do we make sure crypto doesn't
do the same thing? Right. So there definitely is good research that has been done in macroeconomics. It just all happened prior to the 20th century. And there are issues with Austrian economics, commodity-based money arguments, and there's clearly issues with Keynesian-type economics. And the real research on this happened earlier, and that does inform some of the economic design of Quai. One of the interesting things is we can have some of those dynamic systems that do dampen out certain things and remove pieces of volatility, but we don't need to do it at the whim of a committee. We can do it programmatically and algorithmically. So it's certainly something to consider and address. I'm just not going to fully address it right here. Cool? So with that, I will go into what are the shortcomings of current systems. And the biggest shortcoming of current blockchain system is low throughput. And the interesting thing about low throughput is it's that throughput being a constraint is actually one of the greatest centralizing forces in cryptocurrencies and blockchains. Most people don't really consider this, but if you go back to Bitcoin and you go back to the OG days and you look and people were talking about how do we make a completely decentralized system, the focus was on how many nodes can we run? What is the requirement to run a node? How distributed is the hash power? That's basically it. Like those were the three measurements that they put on decentralization. But my argument is throughput is a much, much bigger problem, because if I want decentralization, I want censorship resistance. A great way to accomplish that is to have every single person in the world using that system every day, multiple times to make transactions. At that point, that is censorship resistant. That is highly decentralized. If I have low throughput, I'm going to be economically forced into a layer 2 system. I'm going to be economically forced into a centralized exchange, which is a trusted counterparty, to facilitate lower cost transactions, right? If you look at Coinbase, you can put your money on Coinbase and have free transactions from one Coinbase account to another Coinbase account. That is showing you that if we don't have low cost transactions, people will trade the decentralization. They will trade the security guarantees. They will trade the auditability for convenience and lower fees. So with low TPS, you get these things as emergent properties of the system. One other symptom of this is multi-chains and bridges. Since no single chain, like Ethereum and Binance, can handle all of the throughput, they end up bridging each other using what effectively are poorly constructed centralized exchanges, but trusted entities nonetheless, to make a transition between one chain and another. And then a little bit later on, we'll talk about why that technically is infeasible to make secure. The other thing that low throughput does is it creates unsustainable long-term economics. Does anyone know what I mean by that? Go for it.
I mean, someone's got to pay the fees, so the more you can distribute them, the lower fees each individual is paying.
Right. So with Bitcoin, the majority of fees that are going to miners to maintain security of the ledger and to maintain immutability of the ledger are being paid through inflation. And that inflation eventually goes to zero. At that point in time, the fees for a Bitcoin transaction with the current market cap and with the current size of transactions would be on the order of hundreds or thousands of dollars. So again, that then makes a very difficult system for your everyday user to use in a transactional way, and have that be a reasonable economic system, right? So that's a further centralizing force to say, okay, if that is what we have, we're all going to put our money on Coinbase. Coinbase is going to really do our transactional stuff. And if Coinbase wants to steal our money, they can. And there's really nothing we can do about it, right? Because they're going to be facilitating our everyday transactions because we don't have the size of transactions and the economic wherewithal to pay those fees, right? So one of two things happens. Either we all centralize and everyone's still using it and they're aggregating transactions and paying high fees, or nobody uses it and the value of Bitcoin goes to zero because it can't sustain security. That is the outcome. Either way, it's unsustainable. So we want to design a system that we can answer the throughput problem on and make sure that it's decentralized today and going into the future. So the second issue that we generally have is fungibility. And fungibility is required to allow crypto to function as money. So the two things that happen when I say they can't function as money is if you look at a system like Ethereum, it's highly traceable and it's highly linkable. Everyone's like, that's okay. I'm just going to buy some Bored Apes with it. No worries. The problem is, let's say I'm Starbucks and I want to take my payments in Ethereum and all of my payments are coming in Ethereum. Everybody who's looking at the blockchain can know how much Starbucks is generating in revenue from each store, how many customers, how much they're making per customer, what they're paying to their suppliers, right? So now if I'm one of Starbucks suppliers or I'm, what's the other store now? They're all gone because Starbucks, right? Tea Leaf and Co., whatever, wants to look, they can have all competitive information on me. So just from a corporate competitive model, you can't have open linkability and traceability on a blockchain. Now, this isn't an impossible problem to solve, right? Monero has done a good job of solving this. Zcash has done a good job of solving this. The issue is they can't solve it in a scalable way. So to make money, to let crypto actually fulfill its promise as a ubiquitous value transfer system, you must simultaneously solve scalability and fungibility. So one of the responses to the criticisms that exist is to effectively not address them and create an alternate narrative. So the alternate narrative that currently exists within the crypto system is the infinite token narrative. So people will say, oh yes, Bitcoin can't scale, but it can do this one thing. Or Ethereum, can meet this sort of niche case, and Ripple can meet this sort of niche case. But what we're really admitting every time we say something is a specialization is that we're failing at what we're trying to do. Because deficiencies in the tech create a market opening for specialized tokens. And early on, what did Bitcoin claim to be? Digital money. What does Bitcoin claim to be today? Digital gold. Ethereum, what was the OG claim by Ethereum? World computer. What are they now? Like a base layer, right? What about, well, it's funny. So these were some of the earlier systems, and then people started coming in and they didn't even claim to be money. They didn't even claim to solve like a broader problem. They just said, oh, we're already a niche. Well, the first one that I know that did that was Litecoin, which was the digital silver to Bitcoin's digital gold. Ripple, bank settlements. Avalanche, let's scale some dApps. Shiba Inu, dog means moon. Dog memes moon. Say that 3 times fast. Cardano, we're academics, science, and all these different versions of some specialization or niche which people are trying to serve. But there are thousands of different tokens today that are built and marketed to serve a specific niche. But this is completely unsustainable. Think about if every time you had to go to every store, you not only had to have a store card, but you also had to have that specific retailer's points. So if I went home today and I got to stop at the ConocoPhillips, I would have to have my ConocoPhillips card with my ConocoPhillips points to fill up my gas tank. I'd then stop by Costco on the way home, and I'd have to pull my Costco card out with my Costco points so that I could buy my, brisket, right? And then on my way home, I'd stop by Verizon, and I'd get my Verizon card out to pay for my Verizon service with my Verizon points. This would mean you'd have to have a CD case full of cards with all different tokens and points that you'd somehow have to figure out what the exchange rate was, which ones you want to hold, why, the prevalent change in those exchange rates. This is completely ridiculous. Like, just at its face, it's absolutely ridiculous. And the friction of a many token system is not a market efficient solution if a more efficient solution exists. So if I can make a system where you don't need points for every place that you go, I could have 1 point, I could call it money. That would obviously be a much better solution than having niche specific points. So one other piece to the argument of the infinite token narrative is that we can create bridges and go from one use case to the other use case super easily because it's digital and slow friction because we have bridges. But bridges, in their implicit design, especially in a system which does not have an objective, tightly linked consensus mechanism, are inherently flawed in their security model. And we can see this by the fact that hundreds of millions and billions of dollars continue to get hacked from bridges, right? $2 billion stole this year. I think the peak TVL was like 14 billion. Like, do the math. What was that, 15% of all money in all bridges was stolen in 1 year? Like, that's completely ridiculous, but it doesn't have to do with the teams. It doesn't have to do with the implementation. It has to do that it's a fundamentally untenable technical problem to solve, and it can't be fixed. So what is our goal? Our goal is to address the technical limitations to create a scalable global money. So we're going to address the blockchain deficiencies to create a decentralized currency with the capacity to handle all of global commerce. So the next question then becomes, what is the requirement? You can start to estimate the requirement by looking at credit and debit card transactions processed globally in a given year. And on average throughout the year, that comes out to be about 8,000 TPS. And it's estimated that those make up 35% of transactions. So if we multiply that and then add like a 50% buffer, the requirement is about 50,000 TPS to supplant the majority of transactions that are happening in the world. So that is our goal. We need to create a decentralized system that doesn't create new security guarantees, that doesn't introduce trust, but can scale to 50,000 transactions per second. So Quai, how does Quai aim to do this? Any questions at this point from the previous stuff?
All right, I just wanted to hit back on the infinite token narrative. You made a pretty strong point why we're not going to be able to solve money problems, global money problems, with an individual token for every single application out there. Is your argument generally that there is no use for multiple different types of tokens, or is it that there are use cases that make sense for some types of tokens, but it doesn't generally apply to the problems of money that crypto is here to solve? Did I understand that correctly?
Yeah, I would say that's correct. So if a token is a specific token, but its function within that ecosystem is money, that's a useless token. If it's some alternate form of thing, like a rewards point, so you get loyalty or something like that, there's arguable uses for it, 100%. But the fact that you have all of these systems that basically create a token as effectively money in their one niche is what is problematic and completely unsustainable in a system where you can create a token that can be used as money in all the applications. So who is familiar with this diagram?
Looks like cap theorem.
No, this is the trilemma. So the blockchain trilemma was something that was proposed by Vitalik, I want to say back in 2017. And everyone has promulgated this widely within the crypto ecosystem as Bible. But it's actually a very sophomoric attempt at establishing the engineering boundaries of a very complex problem. And it's not even true. What is much closer, drawing on the academics, is something called cap theorem. One of the reasons we know the trilemma is a little bit fraught is because I can't even define, nor can I measure the points on that triangle, right? If I have to define centralization and then put a quantity around it, how would I possibly do that? Am I going to measure that in kilojoules of decentralization? I can't. It's not a measurable quantity. Throughput's measurable. What about security? Is security a measurable quantity? Maybe, but decentralization certainly isn't. So the cap theorem originates from distributed computing systems and information sciences going back to the 1980s. And basically what it's saying is if we have a distributed database, there is an engineering boundary that exists, and it's a set of trade-offs. And the trade-offs are consistency, data availability, and partition tolerance. Now, when we look at blockchains, we have one other thing that's on here that isn't captured by the cap theorem. And the cap theorem dances around this factor of time, and the time in blockchains for us is tightly related with consensus. So in a blockchain, I could describe a monolithic blockchain with the cap theorem by replacing the word consistency with the word consensus. These are two different things, but all monolithic blockchains force them to happen simultaneously. And that is why they find themselves stuck in that triangle. And so I'm clear for everybody. Consistency is we have the same data. Consensus is we have canonicalized some set of data, which some of us may or may not have. Ideally, the first thing happens before the second, right? But if consensus happens prior to consistency, we now have a delay because we have to catch up with each other. But these properties aren't fundamentally interrelated. They're only interrelated in the design of a monolithic blockchain. So what we're proposing is that we can redesign the blockchain to get us into a tetralemma where our last variable is consensus as measured by finalization latency, and it's independent of consensus. So we can redefine the engineering space. We can redefine the bounds of what is possible within a decentralized system that's trying to create a shared canonicalized database.
What is partition tolerance? Is that the right thing up?
So partition tolerance is if two pieces of the network get separated, am I tolerant to coming back together or not producing bad errors? So there's like different ways that you can treat partition tolerance. One way to treat partition tolerance is I just stop. So if I know who you are and we're in a classical data science situation, I'd be like, where'd Andrea go? I don't know where she is, so I'm just going to chill until I find her again. So we'll just stop execution. The other way to deal with it is we keep going in our independent partitions, but then we have to have a robust mechanism for resolution after the fact, right? So in a distributed system, I obviously can't do the stop thing, because if I'm saying I'm stopping because I can't find you, I have to inherently know everybody who's supposed to be in the network. So that's a partitioned problem. So the way that I must deal with it in a distributed system, like a truly distributed system, is I have to deal with it we have to have a strong mechanism of resolution when a partition occurs and then resolves. Okay, so what is Quai Network? So Quai Network is a merge mined hierarchy of blockchains called a braid. Creating this structure allows us to create performance subnets. It uses a very slight variation on Nakamoto consensus, that being the same proof of work consensus that's used in something like Bitcoin. And it can scale horizontally with demand. So this is one example of a hierarchy. We see that there's 13 chains in the braid. There's the prime chain, the region chains, and the zone chains. But if demand continues to increase, you can increase the number of regions and increase the number of zones with demand to further increase throughput. So what we have here with this hierarchy of a braid is we believe that we can create something that can provide at least 50,000 TPS and a reasonable width of a hierarchy, but can potentially go far beyond that as the hierarchy expands. And I'll go over the trade-off. There is one trade-off, and I'll go over that in the second half. So how does the blockchain hierarchy compare to existing blockchains? So a first-generation blockchain is just one line of blocks pointing back to each other. But Quai Network is this braid of blocks which point back to each other in their context, but then eventually reference the alternate context stochastically. And that's through a process called coincident blocks. And what that allows us to do is it allows us to decouple consistency with global consensus. So we eventually become globally, we eventually achieve global consensus, right? We locally achieve consistency and local consistency. And then we tie the whole system back together eventually globally. And that is that decoupling between consistency and consensus. And what do we call the mechanism that we're using to create a braid of blockchains is proof of work 2.0. So the great part about proof of work 2.0 is it's reliable. One issue with a lot of blockchain solutions in recent years is that they're very centralized, like Solana, with a far lower number of validators with far higher validating requirements. And you know that it's not a decentralized system when somebody can just say, oh, we're going to turn it off for a few hours, day here, day there, and then turn it back on once they've updated the code. Not a decentralized system. If you look at Bitcoin, Bitcoin has had, 6 sigma uptime for the last decade, and nobody can turn it off, nobody can turn it back on. It just exists, right? So one of the great things about maintaining proof of work with proof of work 2.0 is that we create a reliable network. The other thing is that it's secure. And though we have what we would think of classically as multiple blockchains in our hierarchy, it's really a braid. So they're tightly coupled blockchains. And that tight coupling ensures that we get atomic transitions forward, atomic rollbacks. And it ensures we never get out of sync. So we don't have to introduce any new mechanisms like validators or watchtowers or proofs to be able to do transitions between chains, which create a lot of risk that's associated with why bridges get hacked. And then the lastly is it's the mechanism by which we can scale blockchain to global commerce. So instead of having 350,000 daily actives like Ethereum had in November of 21, we can have billions of users a day. And questions on the first part?
How regularly do the zones and the regions, how regularly do they all come back together?
Great question. So the interesting part is that is actually the trade-off. So nothing comes for free if you're really understanding a problem and really proposing a solution to the problem. You're always going to run into something else. There's always a trade-off. So the trade-off that we have is the time to global consensus. Like that's why we say we've moved this out of this. Like, so there's time here. So in a given hierarchy, the width of that hierarchy will dictate the length of a global transition in terms of time. So that will dictate how often they reference each other. So if I have, in that structure, 13 chains, prime will be coincident with zone. So prime will reference the zone. That zone transaction will become referenceable by everybody else once every 900 zone blocks. So that's your global transition time. If you do a transaction in zone, it's still going to take only 10 seconds to complete. So if we're in the same zone and I send you money, 10-second block time, great. But if you're in a far away zone and I want to send you money, it's going to take 9,000 seconds statistically for that to complete. And the wider I make the hierarchy, the longer that's going to take. So it isn't truly infinite because as we increase scope, you're going to have longer global settlement times.
And then, is it true that you can add more regions? You can add more than 13?
Yeah, absolutely.
Okay.
Yeah, and so what we're doing is we're adding the mechanism for understanding network performance and the limit to what we can process is fundamentally uncle rate. So if everybody is willing to pay for the transactions and they're consistently pushing transactions into a zone, that zone is going to keep increasing the gas limit. But at some point, having that many transactions is going to start to cause more uncles to take place. So I can measure the percentage of uncle blocks. And I really need to keep those about below 10%. So I can only increase my gas limit up to the point that I'm getting 10% uncles in that context. At which point, for me to provide more throughput, I got to increase the width of the hierarchy and add another set of chains.
And who increases that? The foundation?
Algorithmically. Because the chain can measure that property. It can measure, are my blocks full? How many uncles do I have? And then it can decide programmatically, should I increase the throughput or not?
It might be peeking into the next section, but you mentioned it can algorithmically decide to increase the throughput. I'm curious to hear what the trade-offs are for that.
The algorithmic piece or increasing the throughput?
Increasing the throughput, so the decision to change how many chains are merge mining together.
Yeah, the trade-off is I get more throughput, but my global transition times increase.
I know that you mentioned that you can add more region chains and thus zone chains. Is there a mechanism for the protocol to remove zone/region chains after they've been added if demand somehow lowers?
So there's two mechanisms to modulate supply and demand, and what you ultimately want to do is match supply and demand. If I can match supply and demand, I will maximize the economic surplus, which means I will create the greatest benefit for the lowest cost. So I can do that by modulating the hierarchy, but I also can do that by changing the gas limit. So say we're getting full blocks and then we bump out by 1, right? And then demand starts dropping off. I can then start squeezing gas limits to get sort of back to filled blocks. In terms of collapsing the hierarchy, it's technically doable, but that's fraught with difficulty and complexity.
Is there like a time limit for the chain to determine demand? Because I could imagine someone like just automating a ton of transactions if they wanted to be like a bad actor on the chain and just drastically increase the amount of chains on Quai.
Yeah, well, so once you run into your uncle limited gas, it's going to become exponentially more expensive to maintain. So the cost of doing such a thing over a reasonable time frame, because obviously we don't want to start adding restructured capacity quickly. Like we need to kind of do that slowly. It would be inordinately expensive to do that as an attack. Yeah.
Is it true that most transactions are geographically sparse? And what I mean by that, it's more likely for someone in Austin to transact with someone else in Austin than it is for someone in Austin to transact with someone in China. So maybe the delay in global consensus doesn't matter as much.
Yes, that is true for your in-person use cases. So if you go to your 7-Eleven, right, that is going to have high correlation with people that are buying sodas in 7-Eleven's preferred recipient address, right? So that's topological. Not topological. That's geographic, rather. Now, you also will have sort of ethereal users, which will also have high correlations, and those sets of groups can decide kind of where they want to transact. So, for example, if I'm looking at Ethereum and I'm looking at OpenSea, there's going to be a high correlation between NFT users and using OpenSea, and that will be a subset of the users of Ethereum, right? So if you're partaking in that activity, they're all going to find kind of a preferred virtual place to get together and do their transactions so that everybody's in the same spot and everybody's doing it inexpensively and quickly. Go ahead, follow.
In those situations, do the users find each other by the system, or how do they match?
Okay, so the question was, in those situations, do the users find each other, or does the system somehow match them? And the answer is the system needs to be self-organizing, but one of the things that you can do is seed an idea. So I don't enforce the idea. I just say, hey, generally, you NFT guys should go off and be in Cyprus. Then most NFT people will naturally group to Cyprus just because somebody said it. Now, over time, even if you don't say anything, like they'll figure it out, but giving a hint will cause faster self-organization.
So as the network scales horizontally and global settlement times across network get longer, do you anticipate someone creating a centralized service that allows users to bypass those settlement times?
I anticipate somebody creating a service, but it doesn't need to be centralized. Once I initiate a transaction in one context, if I were a provider of the service, I can statistically have a risk model to determine how likely I think that transaction is going to land in its destination prior to it hitting global consensus. And for that risk modeling and taking that risk, I could then have money in the destination, which I could give to the person that gave me money in the origin prior to global consensus taking place, and I could take a fee.